Hello?
No,
Hello? Can you hear me?
yes, I can hear you.
Okay. So
Mhm.
I'm Olivier
Yeah.
from ICPAR. I'm working as principal examiner.
Mm.
So we are waiting for participants. I see we have only 3 students. Let me check the number of expected students. So we expect to have around 50 students. I don't know why the attendance is still too low.
Hello. Hello, everyone. Can you hear me?
Yes.
Yes, I
hearing
hear
you.
you.
So can we start now?
Yes, we can start.
Okay. Good afternoon, everyone. We are going to go through this guide. I hope you can see the presentation. We talk about the importance of exam instructions, extraction of needful data or information from the case or scenario given. We talk about time management during the exam. We talk about some of the topics which are common, which are usually asked. We'll see how to approach the question guided by the marks. And then we'll go through the past paper questions, some of the past paper questions. And anything that I will see needful to help you, I'll also talk about it. Now, the first thing we are starting with is the instruction, examination instruction. We have the main instructions which are always given up before the questions. And we have other instructions which we would call the requirements. Those requirements are also instructions. Now, let me look for a question, a past paper question, then I show you. The instruction is very important because if you don't follow instructions, you will not be able to pass. For you to pass, you have to follow instructions. Let me pick this one here. These are the instructions always given. This is business mathematics and quantitative methods, F11. Can pick any paper, not necessarily 2018, even 2021, they are almost the same instructions. These ones which are on the first page. These instructions are there to guide you to see how you prepare yourself. The first instruction gives you the time that is allowed. This paper is always given 3 hours and 15 minutes. The 15 minutes are for reading and 3 hours are for writing. Why do they give you these 15 minutes? 15 minutes is just for you to prepare yourself. Choose the questions which you are conversant with. Choose the questions which are easier for you, that you can do very fast. Highlight them, and then when those 15 minutes are done, you can now see which ones you can choose. The examination is composed of 7 questions, and only 5 questions are to be attempted. So those 15 minutes are there to help you to see how you can get the 5 questions out of 7. You may have studied all the 7, but you also have to be careful which ones do you take. Because of time, I would advise you to choose the questions which are simpler and which can be done within the shortest period of time. The other thing is that marks are allocated to each question and are shown at the end of the question. Then you also show the workings. Now, here, whenever you're choosing, these are 5 questions that you have to do within 3 hours. So it means that these 3 hours, each question you should attempt the question within 36 minutes. 36, when 36 minutes are over, you have to leave that question and go for another one because of time. If you spend an hour doing one question, you may get 20 out of 20 or 18 out of 20, but you'll not be able to cover the 50% of the examination because you have spent the whole time on one question. I will show you the questions which take time. I will guide you. I will show you how you can do them very fast and how you can choose. So if you find 36 minutes are done and you have made a mistake in the first question, please do not cancel that question. Suppose you spent 36 minutes on that question and you found it was wrong, you made a mistake, just leave it, go to the other question, leave space, and then do the second one. Then you can correct that first question that you made a mistake after all the questions have been there, after all the questions have been done. You find that if you do each question within 36 minutes, you can get more minutes to go and complete the questions that you didn't complete before. And this will give you an advantage of passing. For instance, if you got 12, if you did within 36 minutes and each question you're getting 10, 10, 10, you're able to get 50%. 50% is more than getting 25 in 2 questions, which will not help you to pass. That's one. Then we go to the marks allocated to each question. These marks are there to guide you. You see, here we have 3 marks. They are telling, I will talk about these verbs. This is also part of instruction. I will talk about this. If they have given you 3 marks at the end, it means those marks are equivalent to the time. Don't spend more than 5 marks when you are dealing with a question which has 3 marks. Look for the question which has more marks. Here, this one has 3 marks. This one here has 6. This one has 2. This one has 2. This one has 5. The more the marks, the more the time you spend. For instance, this one, you can spend at least between 6 to 10 minutes doing that question. But if you spend 10 minutes doing 2, looking for 2 marks, then you are cheating yourself. Because by the time you go to this one, which has more marks, then you'll fail. You'll not be able to finish. One thing you have to know is that time is part of the examination. When the invigilator says stop, you have to stop. Because they have given you the 15 minutes to prepare, to see which ones you take, and then you start off. Then let's go to this. But before I go away from this, let me come back to the instructions that are given within the questions, which we call the requirements. This verb outline means list, just list. Do not explain, because even the marks are few. But if they tell you explain 3 reasons, you don't have to list. If you list and this question takes 6 marks, maybe they'll give you 3 marks for listing and you lose the 3 marks for explanation. And explanation means what? You elaborate the reason, you give examples where necessary. The good thing in this paper, we don't have those verbs of discuss, explain. It's just, there are few where they will tell you explain. Explain. The rest is calculate, evaluate, advise, compute. Those are the most common verbs that we have here. Let's go straight and see. Determine. When they say determine, they mean you have to calculate. You can do the determination by calculating. Formulate. They want you to form an equation, a function. So these verbs are very important. You have to know them when you're in the exam so that you know what they want. When they say construct, it will be either a table, it will be either a graph, it will be maybe a chart. So you need to know this. Explain, for example, where we said explain the term geometric mean. Here you give a definition, you can even give an example. Don't list. But the good thing with the quantitative methods, you can even give a formula. A formula can also be marked as the explanation. If you don't know how to speak, to write, and you give a formula, then you'd be able to get some marks. Those are some of the requirements, which is part of the instruction. Compute means, what compute also is the same as calculate. They need you to calculate. And the most important thing here, before I forget, give a formula. If there is a formula, for instance, the formula for coefficient of variation, you don't go straight to the solution without giving a formula. Give a formula, if possible, give even the, try to elaborate the letters that are in the formula or explain the formula. But if you find time is going to go, just state the formula and then plug in the numbers that you need to work with. I'm taking some explain. I've talked about explain. I've talked about determination. I've talked about construction. Yes. So we are done with the instructions. We are done with the instruction. Let me go to the workings. It's very important because this is a quantitative course. It's very important to show the workings. You never know the marker, what the marker will depend on to award marks. He may be awarding marks according to the steps. Now, if you think that he's going to give you marks on the last step or the solution, you may fail. And how will he know that you are the one who did the question? Because you cannot just write any number without showing where the number has been from. Show the workings from the start to the end. You never know. Maybe those workings are part of the marks. So state them as clearly as possible and do not be neat. Try to be neat. If for example, you're given a question, don't say I'm going to do a draft and then just work everything within the question. Yeah, hope we are done with that part. Now I'm going to show you how we are done with the importance of exam instruction with everything. And time management, I've also talked about that. The marks there allocated, I've also talked about that, approaching the question based on the allocated marks. You talk about the question, you write the question depending on the marks. You take more time depending on the marks. That one I've explained. And time management, I've told you how to do it. That is 6 minutes minimum for each question. And then you spare some time, you go back and finish up the question that you didn't finish. And also the marks can also show you how much time to spend. Now let's talk about extraction of information from the case. If you don't know how to extract information from a case, it will be difficult for you. I'm going to give an example here of the most where students find problem extracting information is in linear programming. There's linear programming, it seems to be confusing. There is transportation, there is assignment, even decision theory. Somehow you get confused. But I'll show you, giving some examples, how you can extract information from the scenario. Here we don't always have scenarios or cases. We just have the question given, and then you extract the information very clearly. Let me look for an example here and see how we can try to extract. Let's take an example of this question. Let me pick a question here. Yeah, let's talk. See how to extract information from a question like this. If you're lucky and the examiner gives you a linear programming problem in a table, not only linear programming, decision making, assignment and transportation, game theory, all those questions which have tables. If you're lucky and they give you a question within a table, then it will be straightforward. There are many past papers where you find there is a table, especially for linear programming. But there are many other questions, and even decision theory. There are many other questions where you find you are the one who has to draw information, extract information from the question. There is also a trick. They want to know, examiner wants to know, can you get information from the question? Now, question 6, this is June 2018. Question 6, they were asking, a florist owns 100 acres of land and plans to plant 3 types of flowers. The seed for a flower A, B, and C costs 40 Rwandan francs, 20 and 30 per acre respectively. A maximum of 320 can be spent on flower seeds. Flower A, B, C require 1 to 1 working days per acre respectively, and there are 160 days. If the florist can make a profit of 100 Rwandan francs per acre of flower A and 300 francs per acre for B and 200 Rwandan francs per acre for C, required, formulate a linear programming problem. Now, this is a linear programming problem. I want to teach you or to guide you on how to extract information of a question like this. The first thing you have to know, how many decision variables do you have and how many constraints do you have? Because students confuse constraints with decision variables. What are decision variables? Decision variables, those are the decision variables. These are there to guide you to get a decision on how to make the choice that you make on those. They may be flowers, they may be products, they may be anything. When they are given like that, a decision is made on those variables. And those are the ones that you're going to say to put them in form of X and Y, or even Z, if you want to draw or you want to use a simplex table so that it's easy for you. Then the constraints are limitations. You may have 3 decision variables and 3 constraints. Now, it will not be easy for you to know. You need to know which one are decision variables and which one are constraints. So since they have told us that we have 3 types of flowers here, it means these are the decision variables. And these decision variables are the ones which you are going to give the variable like X, Y, and Z. Then you go and look for the objective. The first step is to make a decision, to get the decision variables. The second one is to look for the objective function. Now, you have to first get the objective function first to know, is it a minimization problem or a maximization problem? How do you know it's a maximization problem? If you find the words like profit, contribution, revenue, income, those will guide you to know that this is a maximization problem. Minimization problems, you have costs, you have expenses, you have such things. But they also tell you, in some questions, they will even tell you the maximum profit, like you can see here. Find the maximum profit, hence find the maximum profit. Now, when find the maximum profit, it means that the question is about maximization. And you know when it's maximization, you have the inequalities of less or equal to. Now, let's go to the constraints. Okay, first, if you get the objective function, which is to maximize, first highlight where the objective function will be obtained, like this. You highlight it that way. You say there is a profit for A, for B, for C. Now, this sentence has to go. You don't need it again. What you need is all the numbers which are not in that part. Then, after highlighting that or cancelling it with a pencil, you just now find what are these other numbers? What do they mean? 40, 20, 30, 1, 2, 1, what? You are reducing the numbers which can confuse you. Now what you go to, the next thing you look for the units. Align everything which has the same units. For instance, here, 1, 2, 1, the units are working days. So it means the constraint will be the working days. And you have even the total given here. So it means this one will be 1, 2, 1, or if you have said A, B, and C, there will be X, Y, Z respectively. Then this one will be X, Y, Z. X plus 2, Y plus Z is less or equal to 160. That is 1. The second one, now you cancel. You say this one is done. You highlight with a small pencil. This one is covered. You go to another one and see now that we are remaining with these numbers here. But also look for the units. What are the units? The unit here, we have the currency. We have 40 Rwandan francs, 20, 20. We also have 320, 3,200. Everything is in francs. So you look for the like terms. If there are days, take the days. If there are hours, if there are francs, anything. Take them together, and that will help you to now see what you didn't talk about. Now, for instance, they're saying the seed for A, B, and C costs 40, 20, and 30 respectively, and the maximum that can be spent, you see here, this is the cost, this is the amount to be spent on, is 3,200. Now, this means the 40, 20, and 30, they go together with 300, 3,200. And this one, you call it the expenditure. the expenditure constraint. You highlight with a small pencil, a pencil, and you say that that one is also covered. Then we're remaining with one figure. How about this one, which we have not highlighted? What does it mean? This is also another constraint. They're saying a florist owns 100 acres of land and plants 3 types of flowers. Then what you do, you bring everything like this. I don't know whether you can see. Hope you can see. This is how you do it. You have the variables x, y, and z be the flowers for flower types, number of flowers for flower types A, B, C respectively. The objective function, the objective is to maximize. Then you now plug in, this one is the first one we picked. And then we went to constraints. You have expenditure constraint, you have working days constraint, then you have acre constraint. Acre constraint, the 100 we have seen is X. There's nothing they have told us about it. They have just told us they need 100 acres of land to be able to plant these 3 types of flowers. So you just say, if they have not given you anything, just say X plus Y plus Z is less or equal to 100. This less or equal to is because of the maximization problem. Maximization means this is the maximum. We have to work within this or below. This is also maximum, this is also maximum. But you don't need, you also have to remember the non-negativity constraints. The non-negativity constraints, you never know, the examiner may need to give some marks for this. You just put them there and then you finish. That is what we call the linear programming model. This means you cannot produce less than 0. It either has to be 0 or more than 0. So this is one way of how to extract information if it's not given in the table. But sometimes the examiner will give you something like this. Will give you everything covered like this. Just give you from here. If the examiner gives you the model, you don't need to do anything about the model. Just start straight. Start straight solving the problem. Let me see how, let me see on another question, how to get information from the question. We have a question which is given here. I told you if the information is given, to you, it will be very easy for you if it is given in a table. But suppose now the information is not given to you in the table. They have given you just this. And they have not given you what we call the requirements. This question is a question on transportation. They have not given you, maybe they have given you only this part. They have given you the costs inside, transportation costs like this. They have not given you this one outside. But whatever is not given here is given in the information, just as you can see. 120, 70, 50, which is from this side, 60, 40, 30, and 110, which is down. And they didn't put this for you. They just give you what is inside here. You need to know what is the supply, why are you supplying, and what is the requirement. The source or the origin is always supplying, and the destination will be having the requirement. How much does Rusizi require? Huye, Rwamagana, Nyagatare. You need to know which is which, because you find most of the time students confused and they bring the requirements here. And this is the supply, this is the requirement, or the demand and the supply. You need to know that. But if you're lucky, the examiner gives it to you in the table, then just do it straight away and solve. The other thing I want to talk about is if the examiner says use Vogel's approximation method and you use northwest corner method or minima, Koro minima or row minima, or this is part of following the instruction. Do what they have given you, do what they have told you to do. Don't set a question for yourself. If you cannot do it, look for another question to substitute it. If you didn't read about this, look for another question to substitute this one, but don't do it in the other way. And the steps. In this question, we always have penalties. I didn't do this question, but in the exam, you know, when you're solving this question, you need to have put penalties here and penalties down, and you draw tables, many tables, to get to the final answer. But for the examination purpose, if you can do everything within 3 tables, only 3 tables, you can minimize up to 3 tables, then you'll be, the examiner will mark you because he will see what you have done. Because if you have to draw like 6 tables within this, it means you're going to delay the time, the 36 minutes, you're not going to be able to finish. The same as the other question I've just completed. This question I just completed, the one I was talking about, which has 3 variables. That one can be only done using simplex method. And with the simplex method, you have to draw many tables, many tables. So try to see how you can minimize those tables so that you don't spend more time. Because the more the tables, the more the time. Sorry. Yeah. Do what you have been told. Try to reduce the tables and then get to the other question. This is another way of extracting information from the question. Let me see another. This is not about extraction, but the mistake students normally make. This is another, this is easier. This question is always easier, and if you find it, do it. But the problem is some students fail. The more the question becomes easier, the more even some fail because of not knowing what is required. This is a table which has decision alternatives here, and it has the states of nature or economic conditions. And down here, they will ask you to use max-min, max-max, min-max regret, Laplace decision criterion to choose the best or project among others and explain each decision criteria. Now, it's very simple here. When they say max-min means this is the maximum of the minimum payoff, meaning that you first have to get the minimum, then from the minimum, you take the maximum. Yeah, that's how simple it is. That's how you do it. For max, you first arrange the maximums, then pick the maximum of the maximum. Minimax, first get the maximum, then from the maximum, choose the minimum of the maximum. Now, let's go up a bit. For a student, will think what they want is a number. Remember, this is quantitative methods. This is part of quantitative methods. Quantitative methods means what? You make a decision depending on the value, on the number, which is the quantitative value. Now, if you just give the quantitative value or the value and you don't make a decision, it means that you have not, it's wrong. You don't know how to make a decision. What do they do? For instance, if you want max, the decision on max will say the maximum for project A, we have for B to be 12,080. Then for C, it will be 10,375. Meaning these ones are the maximums, actually, this column. But you can write it here. These are the maximum. Now, remember, we get maximum of the maximum. The maximum of this maximum is 12,080. Now, a student rushes to say the maximum is 12,080, full stop. That is a decision. That is a mistake. This one is not the answer, it's a guide to the answer. 12,080 is a guide. It's 12,080 that gives you project A, project B. You say you choose project B because it has maximum of the maximum payoff, not 12,880, because 12,000 is a quantity and you're choosing based on the quantity. If they ask you minimax, max min, you choose the lowest. The lowest are these ones. From these ones, the lowest is this one here. No, these are the minimums. For the maximum of the minimum is this one. It's the very easiest question, but if you're not, if you didn't understand very well, you may fail. So it means you're going to choose project A because it has the maximum of the minimum payoffs. Hope you have understood that. Never stop there. You may not get any answer, or you may get half of the answer of the marks. So that's the other way. Yeah, the rest, they are not difficult because most of the time these questions are given in tables. They are given, everything is given straight away. The other one is like this one, where they ask you to give the Venn diagram. You have to read. In this Venn diagram, they tell you we have 1,000 households. In these households, 320, they feed on beans. Now, when you're drawing, the sack of beans will take the whole of this. If they didn't tell you only, for example here, if they didn't tell you only beans, it means this is the whole circle for beans. 200 households were on rice. It means that's the whole circle for rice. 450 for potatoes, 150 on beans and potatoes, 70 on beans and rice, 100 on rice and potatoes, and 300 were fed on one of the 3 types of food. So this one will give you the total for the beans, but you need to look for the beans only. Here they need, if they put only, it means this is for only beans. But if they didn't put only, the word only, it means the whole circle contains that. So you can do it that one, and then you see how to do it. Apart from this, the rest are always given straightforward questions. And I hope this is what I thought would be difficult for you. Let me go back a bit to differentiate for you. I want to differentiate for you what always confuses students is also about transportation, and actually students confuse transportation, assignment, and linear programming, but everything is always clear. Now, linear programming, we are not given these values here. They're not given these values here at the supply and the requirement. And we are only given constraints. If it was a linear programming problem, these ones here would be decision variables, and these ones would be constraints. If it is an assignment problem, these ones would be the jobs, and these ones would be the people. For assignment problem, you don't have also the requirement, and you don't have also the capacity and the requirement, or the supply and the demand. They're just giving you the figures in there. Each one has a figure, so you need to just solve it in that way. That is how to differentiate those three, because they always confuse. The other confusion is also on decision and game theory, because even in game theory, we always have the min-max and max-min. For the game theory, they will give you you'll be given the payoff. There's between two, most especially two participants or players. But a decision theory, there are many alternatives, and there are many also constraints. So I hope I've tried to show you how to go through the problem. And now what we are going to do, we are going to see the problems that are always common in the exam, and then we tackle the exam by correction on the past paper questions. I picked a few of them, but there are many, and I'm going to go topic by topic. not going to do the whole past paper. I'm going to go by topic, and I show you which ones are very common. So we are done with this. We are going now straight away to do the revision together. I did the questions and the answers within this document, and I'll share with you later. And I want you to follow so that if you have any question, you can ask. Now, one of the questions, I was going through the past papers, and I found one of the questions which is so common is network analysis. This is the most common question. You have to go to the exam when you know you have read this one. You go and do a small survey and see from 2022 maybe to 2015. Check, when did this question appear? How many times has it appeared? Now, in this network analysis, what do you need to study? You need to know how to draw the network. That's the first thing. The second thing, you need to know how to find the critical path. You need to know how to get the least, we call them the earliest start, latest start, You need to know how to crash. You need to know how to draw a Gantt diagram. You need to know how to find a probability. If you're using PERT, we have two methods. We have critical path method, which is CPM. We have PERT. PERT means project evaluation and review technique. Project evaluation and review technique is a method where you're given many deletions and you have to combine them together to get one. And whenever there is that question which has many deletions, there will be probability. So we're going to talk a bit. I'm going to show you one by one. Now, this one here, list any two advantages and disadvantages of network analysis. So you're going to list two advantages and two limitations equivalent to 4 marks. That one you can do it within 5 minutes and then you go away from there. Because one of the questions that is longer, one of the longest questions is this one, network analysis. But it's also common, it's among the common questions. So what you do, you draw. I told you you need to know how to draw. Now, if you're given the numbers like this, you're given numbers like this. This is very easy, and I pray that the examiner will give you. I wish that if the examiner may give you in this way, they may give you letters. May give you letters in this. It may give you the letters. It may give you the numbers. If there are numbers like this, it's very easy. It means that you are going to draw 1 to 2, 1 to 3, 2 to 4, 3 to 4, 3 to 5, like that. Let's do it. Let me take the table down and we draw together. I show you how easy it is whenever you're given the numbers. They asked PERT, but this is CPM. The CPM, because PERT means you have many deletion. Maybe they did the average of the deletion. So how do you draw? 1 to 2, 1, 2. If I go, if you don't draw the arrow, the most important thing is to draw to show the arrow, because this arrow shows you're moving from 1 going to 2. Activity A was completed after getting an event 2. These ones are called activity. The arrows are for activities, and then the circles are for the events. Events are there to show that the activity started and was completed. It started from A and was completed at 2. You cannot draw, you draw the circle, the event node, whenever this activity A is complete. If it's not complete, don't draw it. So you draw 1 to 2, just as we've seen, then 1 to 2, 1 to 3, meaning that they are starting both at 1. This one goes to 1, this one goes to 3. This one goes to 2, this one goes to 3. Then 2 to 4, 3 to 4. 2, 4, 3, 4, they meet. Five to 6. There's one thing I want to show you here now. This is very interesting. It is very important. Sorry, you cannot get it. Let me rub this one. I'll bring it back later. Yes. Now, this here, 5 to 6. 5 to 6 is from here to this. 5 to 7. You need to know where to put 5 to 6 and where to put 5 to 7. If you put 7 here and you put 6 here, it may not be easy. But you can do it. You can do it. But in case this 6 was joining 9 and you bring 7 here and 6 down, when 6 would be joining 9, it will be difficult. You have to know, where do I put an event closer to another one so that they can connect? You need to know which one is closer to the other one so that you know where to put 6 or 7. But this one is straightforward. 5 to 6, 5 to 7, 5 to 6 to 8 here, and 7 to 8, then 8 to 10, and 9 to 10. Now, in most cases, students they will draw 4 to 10, and it skips 9. You have to see that it's 4 to 9, which was up there, and then we draw from 9 to 10. So that one I hope is clear. This one is easy when they are the numbers is just easy. But if we go to the letters, I'll also show you how to draw them so that you don't. Yeah. Now they have told us to find the earliest start and the latest start. The earliest start is the earliest possible time you can start the activity. Latest start is the latest time possible that you can start it. Latest means if you have delayed it. For example, this one, the earliest is 0, the latest is 0, means you cannot delay. This one, the earliest start is 4, the latest start is 9, meaning that you can delay it from 4 to 9. This one you can delay it 5 days. This one can be delayed 5. This one can be delayed 5. These ones, which are the same, cannot be delayed any day. Now, the examiner may want you to find the critical path using the earliest start and latest start, or he may ask you to find the critical path without telling you earliest start and latest start. So if they tell you earliest start and latest start using the critical, to find the critical path using the earliest start and latest start, you have to do that one. And how do you know this is a critical path using the earliest start and latest start? You're going to do like this. After drawing and inserting the deletion, you're going to do like this. The earliest start, you start from 0 here. The earliest start, you start from the left to the right. You're moving forward. Latest start, you move backwards from the right to the left. Now, how do you do that? This one is 0. To get to event 2, you add 4 here. C, this one, you add 1, becomes 5. Going to 9, from 4 to 9, you add 5 to the first 5. This 5, you get 10. Then you stop because you're going to move from here. When you are dealing with earliest start, you take the highest, because if they are joining, if they converge, if two activities are converging in the same event node, then it means you have to wait and see which one has the highest, because you have to wait. Remember, the critical path is the one that has the longest. For instance, here, we are joining C and D, and we're starting from here. This one, to get to 3, you add 1 to 0, becomes 1. 1, you're going to 3 to 4, which is activity D. 1 plus 1, you add on where you stopped, 2. But here we have 5. 5 was 1 plus 4, which is 5. It means earliest start will take the longest. which is 5. Wherever they converge, you take the longest. Then here we had 2, we had 1 plus 6, 7, 8 plus 7, 15. You come here, we have 7, 7 plus 4, 11. They're not converging. Here we have 1 plus 1, 12, but here we have 15 plus 2, 17. So here we have 12, here we have 17. You take the one which has the highest, which is 17. Now 17 plus 5 is 22, but 10 plus 7 is 17. So you take 22, which is more than 17. Then you start going backwards, you start from here. You write the same number that you got, you put it here and go backwards. Now, when we are going backwards, we subtract. Going forward, we add, going backwards, we subtract. And whenever they converge, we take the one which has the highest. 22 minus 5, 17. 17 minus 2, 15. 15 minus 8, we wait because they're converging here. Get 17 minus 1, 16. 16 minus 4 becomes 12. 12, but here 15 minus 8 is 7. So between 12 and 7, we pick 7. 7 minus 6 is 1. We come from here. We had 15. 22 minus 7 is 15. 15 minus 5 is 10. 10 minus 1 is 11. No, 9. 10 minus 1 is 9. But here we have 1. We take 1. Here we have 10 minus 1 is 9. 9 minus 4 is 5. But here we have 1 minus 1 is 0. So that is it. You finish that way. If they ask you float, the float is the difference between the latest start and earliest. The float is the slack. Is the time you can delay. You can delay the activity. You get this one, subtract this one. Actually, the critical path does not have any float. The float means the time you can delay, meaning that it's 0, 0, 1, 1, 7, 7, 15, 15, 17, 17, 22, 22. But non-critical activities, this one down is the critical path. So you can find the critical path using earliest start or latest start in that way. So the non-critical activities are 10, 15, 11, 16, 5, 15, 4, 9. Those are the activities which you can delay, meaning that all these activities that are not critical, you can delay them by that amount, by the difference. So that is how you get it. I hope you're following. Now, determine the critical path for the network. Since we have used the earliest start and latest start, the critical path is the one where there is the numbers are the same, the earliest and latest. So the critical path for the network is B, E, H, J, K. This lower one, which has double lines. And the duration is 22 days. So that is one way. The question was also asked in 2000, that was 2020. This is 2021 April. They gave us different, this first question we have done is the critical path method, which is given the same duration, one duration. This one is a critical path method, CPM, because they have given you one duration. But when they give you 3 durations, it means that is 3 durations means we have optimistic time, most likely time, and pessimistic time. Now, what you do whenever you see a question like this, one, you know you're going to do expected time, which is the average. The second thing, you know, there has to be probability. Why probability? Probability is because there is a difference between these numbers. And this gap means there is a deviation. Now, when there is a deviation, it means that it's not exact. There's a likelihood that these numbers are between a certain deviation. That's why we look for variance and the standard deviation, and then we look for, whenever we have standard deviation and the variance, we can look for probability. So what do you do here? When they tell you, find the estimated time for each activity. Estimated time is given by this formula. The estimated time is the average time an activity will take. So we have TO, which is the optimistic time, TM, which is the most likely, TP, which is the pessimistic, TE is the estimated or expected time. I've defined them here. And I also require you, if you give a formula like this with letters, you can have different letters, but if that formula is not common, try to define in this way. If you have any other formula which is not this one, but giving the same answer, define it this way. So it's like the examiner does not know. Just define as if you are defining for him, showing that he doesn't know. T is estimated or expected time, TO is optimistic, TP is pessimistic, TM is most likely time. Now you bring this one, you plug in the formula, and then you write here. So what you do, you get 2 plus 4 times 5 plus 8 divided by 6, you get 5. What I want to tell you is that all these numbers, if you want to know that you are wrong or you're right, these ones here, these numbers that you see here, they will always be close to the most likely. They always be close, as you can see. They may be exact or may be close. Now, if you get the numbers which are different from these, the most likely, because the most likely is the average of the optimistic and pessimistic. If you get numbers, for instance, here, you get this one, for the first one, you get maybe 7. When you have 5 here, means you've made a mistake somewhere. So that is how to correct yourself. So this is the expected time, and this is the one we're going to use when we are drawing the table, I mean the network. Because after getting the expected time, the next question will say, draw a network. Now, the previous question, we were using numbers. You remember, the activities were represented by numbers. But this time we are being given letters. Now the letter, I want you to show you how to know how to draw. These activities, these are the activities that are given from the first one to the last one. These ones are predecessors. Predecessors means what? Predecessors means, or predecessor activity means that these are preceding activities. These are activities that come before this one. For instance, A is starting from the origin. The dash means the origin. B comes after A. C comes after A. D comes after A. E comes after B. F comes after C. G comes after D, E, F. That's what you need to know when we are going to draw this. Now, the other thing I want to show you, any letter that you don't see here, any letter that you don't see in here with the predecessor, it means that that letter is the one which ends. Now, we have A, B, C, D, E, F. It means this letter G, which we have not seen in here, is the one which is going to complete, is the final, is the last one. But we may have like 3. We may have like 3 of them which are not here. It means those 3 letters, those are the activities that are going to end the project. You have to know that very well so that you don't, because drawing is also a very big technique in this question. If you don't draw very well, you will not you not get the right answer. This is how you draw it. Practice drawing. So A, the dash means that A is the starting, this is the one that starts. Now A, B, C, D, oh, they're all following A. They're coming out of A. So we have B, C, D. Now you need to be so careful where you're putting these activities. If you put C here and B here and D there, it means you're not going to connect the way I've connected them. So you need to first see where do I need to put B so that it goes up to the next activity? Where do I need to put C and D? If you put D in between, yes, you can even put D in between, it's not tricky. And then it comes straight connecting the two. That's clear. Even B, you can put it in between, and D, you can put it up. That's clear. But if you find that they are connecting, maybe C has to connect to B to get E, it means D does not need to go up. It needs to go down so that B and C can connect. That one you need to, after drawing many networks, you can get to know how to draw them. So the dilation we got here is what we write in here. You can put them here, close, you can put it down. So this is an activity, this is a dilation for the activity. And since they didn't tell you early start and later start, you can get the critical path for this one using just the path. How? Just define the path. You say A, B, E, G. A, B, E, G, A, C, F, G, A, D, G, that way. Because you can get it through that, or you can get it through the early start and later start. If they didn't tell you about the early start and later start, just write all the activities and find all the paths that are there, and find the path that gives you the longest. So as you can see, we have three paths, the one moving up, the one in the middle, and the one the lower part. All of them are giving the periods here, and you need to know which ones are they, the days or weeks or month. Now you look through these ones and find which one has the highest. 28. 28, the one that has the highest. So you say the critical path is A, C, F, G, with the project duration of 28 days. Now I told you whenever you have these three periods, optimistic, pessimistic, and most likely, you are going to be asked the probability question. And the probability question is given here. Find the probability that the project will be completed in 30 days or less. 30 days or less means from 30 and below. That is the maximum. So what is the probability of completing the project within 30 days? You first look for what we call the variance. And the variance, because we are taking 28 days, this is the expected duration period. We got it from the expected time. So this is the expected duration period. Expected duration, the expected duration is the mean. Now we want to see what is the deviation from the mean. You get the highest minus the lowest. The highest is pessimistic time minus the lowest optimistic time, divide by 6 and square, because the variance will square. But you do this for only the critical path. Why the critical path? Why do we do this for critical path only? One, there are two reasons. One is because it's the one which has the highest, the longest, duration. The second one is the one which gives you the average. This is the average, this one here. So you're going to look for that. Okay, in case you have a question, go to the chat room and then write your question. Just type your question and then I will read it and answer you. So we have the optimistic time, pessimistic. These are the highest and the lowest. The lowest is 2. Remember you had A, C, F, G. So we're going to look for the variance for A, C, F, G. Like this, you get 8 minus 2 divided by 6 square. You get that one. 10 minus 6 divided by 6, you square. 8 minus 6 divided by 6, you square. 10 minus 6 divided by 6, you square. This is the variance. 1.99 is the variance, but we don't need the variance. We need the standard deviation. And standard deviation comes from the variance. You just get the square root of this one, which is given here. So you have the mean, duration, mu. This is mu, which is representing the mean. And this one, the theta, which is representing the, no, sigma. Sigma, which is representing the standard deviation. And we'll have x. This x is always in the question. So you have this formula which says x minus mu over standard deviation. Let me first check this question. Yes, they're saying yes. Okay. We'll type the question and we'll know. The probability of completing it within 30 days or less will be written like this. 30 days or less, when we have x, it will be 30 less or equal to x less or equal to 30. And we are looking for the probability of this. So what we do here, what we do, we're going to plug in this formula here, we put it here, we plug in the values. We have x, which is 30, we have mu, which is 28, we have standard deviation, which is 1.41. Yeah, it's asking the 6 we get in the formula, where do we get it from? Is the formula. After deriving the formula, they have, this is in the formula. That 6 is in the formula, whether on a variance or expected time. You have that one in the formula. Where is the expected time? Yes, the expected time, I gave a formula, this one. There's also 6 here. So this 6, on expected time, you have the 6 here. On the variance, you have the 6. You also have 4. So this, the one who derives the formula, is within the formula. It's just a formula. You don't need to do anything about it. And they will not ask you to derive that 6. Just to get to know that it has to be there. I hope everyone knows this formula from probability distribution when you're dealing with the normal distribution. Is there no any effect when we find variance on only critical path on the mark reward of the variance? Oh, unless the examiner, if the examiner tells you find the variance for each. You see here, this question was saying, this question one was saying, find the estimated time for each activity. If the examiner tells you find the variance for each activity, you have to find the variance from A to G. A to G. But if the examiner just tells you the probability, he wants only the probability. He will not ask you why didn't you find the variance from A to G. Just go look because of time. If we had time, I would do that. But remember, time is part of the exam. Just go straight to, just pick the critical path. Or if you can do it very fast, get A, B, C, D, E, F, G, and just highlight the critical path like this. Just highlight those which are critical, take them and add them. But the reason I just did this, I didn't want to confuse you. I didn't want you to add up from A to G. That's why I intentionally picked the critical path, the critical activities, because, yeah, I wrote it here. First, find the variance of each critical activity. The reason I did it, I didn't want you to add from A to G, everything, even B, even E, even D, which are not necessary. Unless the examiner asks you to find them specifically, do it, because there is a mark for each activity. Because the reason he asked you, he's going to award the mark on each activity. But if he doesn't, don't bother yourself. He's going to give you the marks for, what he's going to do, he's going to give you the marks for this one and this one. And the other thing he wants to know, do you know how to get standard deviation from the variance? Do you know how to plug it here in this formula? And even, do you know how to read from the table? That's very important. If we get to probability distribution, I'll show you, but even here, I want to show you what to do. Now, if they have asked you the probability, less or equal to, it means if we are to draw, I don't know how to draw. Draw like this. Like this. It's a bear shaped. Sorry. Sorry, just take it like this. We are drawing 30. That is like this. And we need 30, that is here. This is for X. It means we are drawing this. We need this one, this part, only this. So we have to change these X's into Z score because we need to read from the table. Now, how do we change the X? This is for X. We will need to change it into Z score. Z score means it's measuring standard deviations away from the mean. And this would be the mean. The mean would be 28. If we are taking the mean would be here, 20. No, to be less. The mean would be, this would be 20. This would be 30. 30 would be more than 28. 30 would be like here. And then this would be 28. So the mean is in between here, which is 28. And 30 would be here. So what we need is the whole of this up to here. Now, what we do, we change this one into Z. When we change this into Z, it will be, this will be 0 because it will be 28 minus 28 over 1.14, which is 0. And because this is beyond mean, it will be 30 minus 28 over 1.41, and this one will be Z. So this one will be Z, and we'll have we have 0. This one under Z we have 0, and after 30 it will be this value, this one which we got here, which would be 1.42. And in Z, remember we're reading from positive, negative infinity to positive infinity. And these are what we call the Z scores. Now, each Z score, these values here, these are standard deviations. This is 1.42 standard deviation away from the mean, and the mean is 0. If we get the negative side here, we'll get negative. So this area under the berry is what we call, is what is representing probability. And the figure below is the standard deviation. So each standard deviation has a probability up. We go to the table, we'll have the table, we'll read from the table, which you call the normal distribution table. Someone is asking if the probability is less than 20%, find the probability of completing it in 24 days. Help us to know it. It will be either, this question is not clear because you're having the probability and then you're asking the probability. Maybe if you say it's 20% of the, if 20% of the dilation is completed, find the probability of completing in 24 days. But if you say, if the probability is less than 20%, find the probability of completing it in 24 days. It will not be clear. Otherwise, you would say, if the dilation is completed in less than 20%, what would be the probability of completing in 24 days? For instance, we're going to calculate 24% of 28, 20% of 28, because 28 is the what? For instance, 20% of 28 is what? 20% of 28 is 5.6. So you get 5, you get 28, this minus 28, 28, then it would be 22. The question would be, if the project is completed, if the project is completed, if the dilation of the project is completed in less than 25%, what would be the probability of completing the project in 22 days? So what we do, we get the dilation, which is 28, we multiply 20% of the deletion, we subtract that, and then we come up with 22. Then you ask, what is the probability of completing this, the probability of completing the project in 22 days? So 22 is less than 28. Now, what we will do, I'll come back here. I'll come back here. Maybe that question was not set well. I'll come back here and bring you. Let me come here. In X, the project is completed in 28 days. Now, what's the probability of completing 20% and less of this? Will be 22. 22 is here. 22.4. Let's take 22. So that would be clear, because if you tell me what's the probability of 20% of completing the project, it's not clear, because you have the probability already and you're asking them, unless if they tell you the probability of completing the project is 20%. Now, how many days? There are two ways you can ask. They give you the probability, which is this one, and they ask you X, this one. That's one way. Or they will give you the percentage of these days, these weeks, having reduced them, and they become 22. And then they ask you, what is the probability of completing this period? 20% less of 28 is 22. And then they ask you the probability of completing in this. Or if they don't ask you that, they'll give you the probability. Let's say it's 20%, the probability of completing the project is 20%. How many days should it be completed? Those are the two ways the question can be phrased, and the examiner, it's clear to the student that the question was clear. But this question which you have asked is not clear either to me and even to the students or the candidates going to do it. So I hope you have understood. 20% more, they can even tell you 20% above 28. And then you find 20, if it's 20% more, if you can increase 20% of the days, you can say, let's increase these days by 20%. We get 20%, we get 28, we multiply by 20%, we add it on 28, and then we find more. It will be more than 28. If you want below, you can reduce it and then find the question. I hope it's clear now. The one who asked. Okay, I'll check, but that is clear. I hope it's clear now. That's the way they will ask you the question. Now, how do you know this one? Go to the Z table and read 1.42. Hope everyone knows this table will be given to you in the exam. Don't come with it. Don't. And remember, this is not an open book question, so don't fear, don't worry about where to get the table. The table will be given to you in the exam, and you'll be able to know how to, just what you need to know is to know how to use the table. Okay, let's go and read 1.42. So this part is the negative side. When you see it below this one, this is the middle point. This is the middle point here. If it's below this one, it's a negative. It's above, it's positive. What we had there is positive. So you look for the numbers which are in positive. Our number was positive, so we go and look for positive 1.4. 1.4. 1.42. Where do you get 42? You read here 1.4, then the 2 is here. This one. So it is 1.42. Then you read the percentage, the probability, which is given here. These points means 0.5, 0.540. Those dots mean 0. So the probability is 0.92. What does that 0.92 mean? The probability of completing the project in 30 days or less is 92.22%. That is how you interpret. For us to complete this project beyond 28 days, we can have a chance of 92%. There is a chance of 92% of completing the project in 30 days and below. Now, we are going to talk about probability distribution down. I'll show you how to get more, less than, or between. Because this is probability distribution, which is dealing with continuous variables. Continuous variables means it's from one part to another. It is an interval. It's not one probability. August 2021, what am I looking for here in this question? For state any rules. Now when they say state, you can even stop here. Say each activity is represented by one and only one arrow. You stop there because it is stating. But here I just put the answer so that you understand. This is for you to understand. But stating is a line. It's one line. Not two activities can be identified by the same events. You can even stop there. Stating is only because if they have said state 4 rules, 1, and they give you 4 marks, it means one rule is 1 mark. You don't have to waste time because there is time for other things here. They've given you this table, and what do I need to bring here? What we didn't talk about above. Because we have talked about CPM, we have talked about PERT. PERT is where we have probability, standard deviation, and expected duration. And we have done the drawing. We have found the critical path. We have done earliest start and latest start. What haven't we talked about? What we haven't talked about is this Gantt, the Gantt chart. That one. And what else do we need to talk about? Crashing. So we need 2 more things to finish the network. We need to know how to draw the Gantt chart. We need to know how to crash the project. And when you know all these 4, you will be done with the network. So here they have given us time. Now, when you see only one duration like this, there is no optimistic, pessimistic, most likely, you need to know, that there will not be a probability, because they cannot ask you the probability when they have given you one duration, unless they give you the standard deviation separate, and they give you the mean, which is the expected duration, separate. But if you find they are giving you this without giving you additional information, straight away you know that this is what we call CPM. This is CPM method. CPM. CPM means what? Critical path method. Critical path method is different from PERT. PERT means what? PERT means project evaluation and review technique. Project evaluation and review technique, it has pessimistic time, it has optimistic time, and it has most likely. This is the difference. The difference between this and this, here we have only one dilation. That means it's CPM. PERT will have 3 dilations, and within the 3 dilations, we can be asked to find probability. So whenever there is probability, it has to be when we have this that you need to know. But when they ask you the float, they can ask you float from here and the float from here. They can ask you LS start here, latest start. They can also ask you LS start and latest start. So this one, we have only one dilation, which is given here. So when we have one dilation, it is CPM, critical path method. He's asking, how can we find on the table like between 0.34 and 1.9? Very good question. Let me draw it here. 0. We have 0.34. And we have 1.9. So what you need to know, you will be looking for this part, the shaded part, which is this one. You go to the table. Let me bring back the table. .4, you look for here, 0, because it's positive, 0.34. 0.34 is given here, 0.34. You read this value, 0.34, this one, 0.6, it will be 0.6331. Then you go and read 1.9. 1.9 will be here. This is 0.8621. Now, after reading those values, you go to the question. Now, what you do, you do like this. Probability because these are Z, you're going to say 0.34 less than or equal to. You can even say less than Z less than 1.9. What does this mean? This means that you are reading from where I showed you between, because they are between, you're going to have, let me draw again, it has gone off. From here to this part, this one. This is 0.3. 0.9. Okay, now from here to here, we read like this. This we read like in this way. We are reading we're reading from negative infinity to this point, and also read from negative infinity to this point. So we're going to read for this value, and then we read for this one, and then we get this one, we subtract that. So we're going to read after getting the values which we got, meaning this, for this one, it's 0.633, and this one also is 0.8621. So you read, if there are two, you get the one on the right, you subtract the one on the left. You do like this. Probability of Z equals 1.9 minus probability, because there are two and you want Z equals 0.34. Then you just go here, come here, get the probability of 1.9 is 0.8621 minus 0.6331. Which will give you 0.229. 0.229 is 22.9%. This is equivalent to 22.9%. That's how you do it if you are given 2. But if you are given more than, suppose they were asking you more than 1.9. If they ask you more than 1.9, it means that they want beyond 1.9. For instance, it's like this. They want beyond 1.9, and 1.9 is here, so they want this part. What do? You get 1. Remember, we read that this, the whole of this part is 0.8621. So you get 1 minus this, then you get the other side. Hope it's clear. I hope it's clear. That's when they ask you the other side, this side which is not given. The whole of this one is 1. You subtract 0.86, then you get the remaining part. If they have asked you beyond or greater than, we come back to this when we go to probability distribution. Okay. Now that you have understood, let's see how to draw. Let's show you. I told you these are predecessors or preceded by. When you see 2 dots or dashes, it means A and B are the starting. They are the ones that start. C will follow A, D will follow A, E will follow B and C, E will follow, F will follow B and C, G will follow E, H will follow E, I will follow D and J, J will follow F, H, I. Now, which letter don't we have here? Which one doesn't appear here? Let me see. A, B, C, D, E, F, G, H, I, J. It means we have only 1 we have only one activity that is completing the project. So you need to know that. So we come back, we come down here, we draw. This is how we draw it. This is how it was drawn. Is it disappearing? Yes, this is how it was drawn. A and B, they were starting. And D and C, they were following A, just as I showed you. Just as we saw, B and C, E is following B and C, F is following B and C, just like that. So E and F, they are following B and C. B and C means they have B and C have to be completed to give E and to give F. And we have found that E is giving G and H, and I is coming from D and G. I comes from D and G, E is giving G and H, and then J comes from FG, FHI. FHI, like this. FHI, they are giving J, and J is completing because we didn't find that letter there. Then you write these ones, these numbers. These numbers are the duration that was given. And so if you are not given the earliest start and latest start, you can arrange them like this. You can arrange activities in this way. A, D, I, J, this is the first one, 37. A, C, E, G, I, J, this is the second one. A, C, E, H, J, this one. Then you say A, C, F, J, this one. Then you come to B, B, E, G, I, J, B, E, H, J, B, F, J, like that. And you look for the one that gives you the highest. So among these ones, we have A, C, E, H, J, the one that has the highest. So the critical path is A, C, E, H, J, and the project duration is 54 weeks. What else do they ask you? They can't. Now this one, the Gantt. How do you draw the Gantt? The Gantt chart. You write the days down. The days have to be written down. You can write them up here. In some books, they show you writing them up here. In some other books, you can write them down, whichever you want. You can put it here. You can put the days here, or you can put them down. Then activities here, you have A to J, and you say A has 15 weeks. How many did we find? The critical path was taking 54. So you say this yellow one is for A, is taking 15 weeks, but also B is also taking 15 weeks. You draw it close to B, where B is, you see this is B. C, remember C starts when A and B have been completed. So you started here. How many days is it taking? 3. 1, 2, 3. So you add 16, 17, 18. But D is taking 5 days and is starting also when B and A have completed. You add 5 days. E comes from C. You remember we said E is coming from C and F is also coming from C. How many days does E take? E is taking 8 days. You count 8 days onwards. F is taking how many days? 12 days. You count 12 days afterwards. The next one is G. Where is G coming from? G is coming from E. So you write how many days from E? 1 day from E. H is coming from E. It's also coming from E. How many days does H have? H has 14 days. You write, you count 14 days from there onwards. I has how many days? I has 3 days. You count 3 days from G. Yes, 3 days from G. Count those days. J, this one, the last one. J is taking 14 days. And J is starting from where? I was supposed to start it from here. This one is not there because it starts when I has completed, because I is the one taking long. I'll correct that one. So it starts from here. You count how many days? 14 days. 14 days going onwards, then you complete. That is the Gantt chart. Now, what is remaining in the network? What is remaining in the network is crashing. I want to talk about crashing, and then we'll get done with that question. We have covered everything that deals with the question. Now, the examiner would like to ask you how to crash. Someone is raising the hand. Just do Simon Acromans, write the question in the chat room. We'll be able to see how to answer. Now, here, this question has the cost. This normal, you can see, this is the normal cost. This is the normal time, the normal cost, the crash time, and crash cost. What does crash mean? Crash means that a reduction. If you want to reduce the duration, we can increase the cost. An example is if you want to finish a house within a short period of time, it means you're going to increase the number of workers and also increase the cost of purchasing those materials, even the cost of hiring the workers. So if you want to reduce the project duration, you increase more cost. The more you reduce the number of days, the more you increase the cost. So the normal time is 6. The crash time is 2. It means the cost will increase from 50 to 100. If we crash this one, 3 means there's no 40 means there's no, you cannot crash this activity. 10 to 6, we can reduce it from 10 to 6, but we incur a cost from 40 to 120. If we crash it from 4 to 2, we incur a cost of from 10 to 20, like that. You go on doing it that way, and then you find how much is the cost of crashing one activity. We do what we call the cost slope. Cost slope is the crash cost minus normal cost over normal time minus crash time. Normal cost is this one, crash cost is this one. So crash cost is always higher than normal cost. As you can see, 50, 100, 40, 40, 40, 120, 10, 120. The crash cost is more because you are reducing the time, increasing the cost. Then normal time and crash time, here we have normal time is this one, which is always given. Then the crash time is this one, meaning that for the crash time, for the time, there is the normal time is more than crash time because crash time you are reducing the time. This is a slope, meaning this one is assumed to be a linear function, a linear equation. If you are drawing the linear equation, you'll find that the slope is somewhere between the cost and the time, and then you get the gradient. That cost means what? Per unit, per one activity, how much do we have to incur to reduce that? So you do it this way. This is the time, this is the cost, this is the crash time, crash cost, this is the activity, this is the change in period. Change in period is 6 minus 4, minus 2 is 4, 3 minus 3 is 0, 10 minus 6, 4, 4 minus 2, 2, 2 minus 1, 1, 3 minus 1, 2, 5 minus 4, 1, 7 minus 5, 2. That is the change in the time. The change in the cost would be 100 minus 50, 120 minus 40, 20 minus 10, 20 minus 5, 80 minus 20 minus 15, 80 minus 40, 120 minus 50, 70, and 200 minus 80. These are now the changes because it's change in X and change in Y. The X is the time, the Y is the cost. So you get these ones, you divide by this. You get the cost slope, which is given here. What password we can use during the draw Gantt chart? Assume we have critical pass of 110, 19, but no size of booklet is okay. You can just reduce. You can reduce, you could use an interval of 5, 5. You can use the interval of 2, depending on how long that is. This one I did it intentionally to show you how to draw the chart, but because of time and space, you just have to draw, to give a scale, a smaller scale. 5, 10, 15, 20, that way. And then you estimate in between 5 and 10, where is 8, where is 7, that way. Instead of drawing 54, we can just say, you can say 10, 20, like this. The reason I did the whole thing was intentionally to show you how to do it. But here you can say 10, 20, you put from 10 to 20 here, like here, put here 10, 20. Anyway, you find a scale which is not big, and you find that this 50 is up to here, maybe here. And if you're looking for 24, you do an estimate somewhere between 20 and 25. If you're looking for 21, an estimate between 20 and 25, 30 to 35, like that, or 30 to 40. You don't need to write all these numbers there. This one I did it intentionally to show you, but you can see it took too much space. But within the exam, I told you try to find the way you can reduce time and space. That's why I was telling you even the graphs, the tables, reduce the tables. This one also reduce the space, because writing all these numbers from 1 to 54 is difficult. Just say 10, 20, 30, 40, 50, 60, and estimate between the lines. Hope it's clear. This one, because of revision, we are doing everything and we're taking our time to know everything, but in the even this one here, even this table here, you don't need to put all these ones. You just put this, and put here. This one you can even remove it, put the cost slope here. Straight away you put these values, these ones. You don't need to put these. This is just for explanation so that you follow. Because of time, it will take time. Just put it here. These ones, remove them. This one is to help you draw. You did not need to have this one. Bring this column here. Remove it after drawing. This one is done. We don't need this one after drawing. Okay. Hope it's clear. Because of revision, we're trying to be detailed, doing everything within. But you have to show the working. Though we have said you don't do this, you have to show the working down here for each activity, how you got these values. You can even do 1, 2, 3, 4. Because it's not marking the slope. If he asks you cost slope, let me advise you. If the examiner asks you cost slope, it means on the cost slope is giving marks for each activity. But if he's asking you crash, it means the most important thing is about crashing, not the slope. So for the crashing, you need to summarize. But if the question is specifically saying, find the crash cost for, the cost slope for each activity, it means you have to do for each one, do a formula and give each value showing the working. Okay, good, it's clear. So try please to see how you can minimize time. Now, since our question is not about cost slope, but crashing, yeah, okay, before I forget, what will they tell you to crash? How will the examiner require you to crash? He may ask you to crash the activity up to a certain cost. Mulimo kubona hano, Ronald Franks, na amafaranga normal cost. He can say, we want to crash this activity up to, because you know when you are crashing, you're increasing the cost. He may tell you to crash up to 500 100 francs. That's one way. You are crashing based on the cost. Or he may ask you to crash based on the duration. We're having, this path has 23, which is the highest. This one has the longest, sorry. This one has 22, this one has 17, this one has 6. So he may require you, if he requires you to crash based on the duration, he requires you to crash from 23 to 20, for instance. He may require you to crash from 23 to 20. Reduce it 3 days. Or he may require you to crash from 23 to 17. This one here to 17. Or if he doesn't tell you to crash from 23 to 17 or from 345 to 500, he may tell you crash 4 days. If this specifically, he will specifically tell you to crash the activity, crash it 4 days. So you need to know how you're going to crash the activities that you're given. Those are 3 ways he may ask you, the examiner may ask you to crash. So let's go. After having the cost slope, everything given, what are the criteria for crashing? We crash only the critical path. The critical path is A, C, H. So these are the activities we're going to crash, starting with these ones, because we need the critical path to continue to be critical. If you crash and the critical path is no longer critical, then you have made a mistake. And the examiner cannot ask you to crash until the critical path is no longer critical. Or you have another critical, you may have 2 critical paths or 3, but the original one has to still be critical. So this is the normal cost. The diagram is given here. Our critical path is given. ACH, as you can see, the normal cost is given. Let's see what they needed. Oh, they can even ask you to crush the critical activity to the optimum level, meaning crush the project until you cannot crush it anymore. You see here we have 4 days. Crush it until these 4 days are done. Until these 4 days are done. Until these 2 are finished. Until this one is covered. This one is covered. This one is covered. Until everything here becomes 0. That's what they mean. Crush it to its optimum level. Crush it until the project cannot be crushed. They're not specific. They're not telling you about cost. They're not telling you about time, but they're telling you to crush until these changes are not there. If you find that the critical path stops here, you can't crush it until it goes 3 times. Just stop. Stop wherever the critical path is done. Okay, he's asking, for every crushing, is it necessary to draw other network again? Because of time, in here, I drew many networks because I wanted to elaborate. Here you can see there are many. Each time I crush, I draw. Each time I crush, I draw. But in the exam, because of time, don't need to draw these ones. Don't need to draw them. Just what you need to have is this table. This one here. This one. This one is the one which you have to show. What does this table show? This table is showing you each activity. We started, the normal duration is this one, 23. We crushed A. A was the cheapest. You can go and see, remember we're crushing ACH. ACH. You start with the cheapest from the critical path. The one which has the cheapest cost, the lowest cost from the critical path. We have 5, 5, but 5, 5, they are not on the critical path. We're going to compare A, this one, A, C, H, because we start with the critical path. Which one is the lowest among the 3? We have 12, we have 20, and 60. So 12 is the lowest. We start with that one. How many times can we crush it? 4 times. If we crush it 4 times, we incur a cost of 4, 50. But you crush depending on how, if it will not affect, what is the difference between the first and the last is 23, 24. So if we crush A 4 times, it means that this one will become a critical path. So we crush it 1 day to make it 22. Are you following? We crush it 1 day to make it 22. If we crush 4 times, we'll go below 22 and the critical path will no longer be critical. That's the most important thing. Crush 1 by 1. If we had a difference of 4, maybe the next one was 19, we would crush this A 4 times and we get it to 19. So let's come down here. This was supposed to be crushed once. Yes, we crush it. We crush A 1 week, not 2 weeks. If we crush it 1 week, then we get the cost. Then we subtract, we add the cost onto what we had here. Then we get this one. We go to the next one, which is the cheapest. C is cheaper. C is cheaper. How many times can it be crushed? 4. If we crush C, do we have C in this other? Yeah. Oh, A, if we crushed A, it would affect, A would affect this critical path and this one. If it affects the 2, there's no problem. Sorry. Here it has to affect the 2. Yes. because it affects 2, it affects the 2, you can crush it 4 times. When you crush it 4 times, the one which had 22 will go to 18, and the one which had 23 will go to 19. You can see 19. Then we crush C. C here. C is not in here, but is here. And C has how many times? C can be crushed 4 times also. You also crush it that way. You go on crushing one by one, one by one, one by one, depending on how many days are remaining and how many critical paths are still remaining. Then you get to the last one. So someone was asking, you don't need to draw these diagrams, these ones, because here we crushed 2. When you crush, you will say it is crushed. Here we crushed C, the second, then we crushed, the next one was D and E. Both of them, we crushed them simultaneously so that they don't affect the critical path. Then we crushed, the next one was G. We crush it so that it does not affect. You can see 13, 13, 13. Means we have 3 critical paths here. But before, we had 15, 15, 15 still. So there is G, this G, and this G. When you crush it, it affects everything. You crush it, then we crushed H. When you crush H, it means all these are crushed apart from F. So we don't need this F. When everything is crushed, this is the additional cost. It means that we crushed until 660. The original cost, which was the normal cost, was 345, and the additional cost is 315, meaning you're crushing the project from 23 to 13, 10 days off. This is how you do it. You don't need to draw all these ones because you don't have time to draw them. Just present them in the table. If you want, you can only draw the last one to show that everything is crushed, but the main thing is the table. Okay. Yes. This is another question. In this question, it was tricky. What they did here, they didn't give you they give you crushing cost. Crush dilation, crushing cost, normal dilation. Meaning this one is the change. Everything is changed. And this one is the normal dilation, this is the crush dilation. So they didn't give us the normal cost and then the crush cost. They gave us the change. So they called it crushing cost, but they gave us the change. So it's tricky here. You need to know that this one is the change. So you need to get the change of the period down. And in drawing, let's check what don't we have here as the last is M and N. M and N will be the ones to complete the dilation. What did they ask? Determine how long it will take to complete this project, assuming that each activity is done in normal time. What they want here is you to have the dilation, the critical path. So you draw, this is how we draw. The critical path is 24 months and it's BEGJLN. Then the management would like to have the project completed in 20 days. Are you seeing? Month by all means. Determine the total crush cost that will be incurred when the management objective is adhered to. Now, what they mean, they want you to crush it from how many days did it have? 24 to 20. You see how specific it is now. Crush it from 24 to 20. How many months are you crushing? 4. Where are you going to get the 4? Get them along B, E, G, J, L, N. The first one has 24, the next one has 20. You see, the first one has 24, the next one is 22. So we are going to crush 2 months up to 22. Then we crush together 22. We crush together this one and this one. We find two more months which we can crush together. So for you, after getting the cost slope, you're going to look for the cost slope is given here. So we find that B, E, G, J, L, which one is the lowest? 4,600, 0. This 0 is crushed. We don't need to crush it. 600, 1. So 600 is the lowest. G is the one which can be crushed. How many times can it be crushed? G can be crushed from 4 to 3. It means has only 1 day to crush. First crush that one day. It means you're going to increase 600 onto the normal cost. We had, because 600 is for the days, the month. For 1 month. 1 month. Then look for the next one. The next cheapest is J. N. N can be crushed also once. So you can crush G once and N 2 times. Once also. So you crush 2. G and N, each crushing them 1 month. You have reduced 2 months from 24 to 22. Then you look for what is the intersection between this one. So if you crush N and J, it means it has affected this one. It has also affected this one. It means this one will be 21. This one will be 23. If you crush J, if you crush G, do we have G in the 2? Yes, there is G. It has also affected this one. So this one has been reduced from 22 to 20. This one has been reduced from 24 to 22. So we're going to look for another one which we can crush, which is not within these 2. E is already crushed. J, yes, we can look for between B, J, and L. B, J, and L, which one can be crushed? Next, J. J is the second one. We can also crush it 1 time. Then we are getting to 21. Those are 3 days off. Then we look for another one which has some period. The next one is L. Also can be crushed once. So you crush each activity once. We crush G once, J once, L once, N once. Those are 4 months that you have crushed, and you add you can see we add them here. You can even crush G 3 times because G is affecting the 2. If you want, you can crush G 3 times. But is it crushed 3 times? Let's check. No, it's not crushed 3 times. It's crushed once. I'll correct that one. It's crushed once. It can be crushed up to this. So you crush G, J, L, N once, and then you complete. Now we are done with the network. That is one of the commonest questions that you find. The other thing I didn't talk about is the float, but the float is easy. You can go free float, independent float, total float, you can find them. The float is the same as slack, and slack is the time period you can delay the project. Which other question is common? Hypothesis. hypothesis is another common question in the exam, and which is trickier for the students. Why? Because there's probability, and there's mostly four main tests that we find in probability, in hypothesis testing. You need to come to the exam knowing these four tests, but especially two of them. Those are the common ones. No, three. And here they're asking, write short notes on the following tests. If you see 2 marks, these 2 marks match, you need to explain, don't state. If they say write short notes, don't state, don't list. So explain something, though it is short, but say something. Now they say normal tests, these are tests, they test a sample mean against population mean, whereby the sample size is greater than 30 and the population variance is known and the sample proportion, where the sample size is greater than 5 and NP is greater than 5 and NQ is also greater than 5. Since this case, the normal distribution can be used to approximate the binomial distribution. Now, the thing for a normal test, how do you know this is a normal test and not t-test? For normal test, n is always greater than 30. When you find in the exam, the sample size is greater than 30, you know that the test I'm going to use is normal, and you use the normal distribution. How about t-test? T-test tests the sample mean against population mean, the same as that one, and especially where the population variance is unknown. The population variance is not known, but here it is known, up there it's known, and here n is less than 30. Now, for you to use a t-test, n has to be less than 30. 15, 20. If you find in the equation there is a sample size of 15, of 20, of 16, of 22, 28, you use a t-test. But if you find 50, 70, 100, you use normal test. Variance ratio test or F-test is used to compare population variances and is used with samples of any size, any drawn from normal populations. So this one can be used from beyond even 30. Chi-square test is used to test the association between attributes or the goodness of fit of any observed or frequency distribution in a standard distribution. So these ones, all these ones have a table. They have different tables. There's a table for t-test, there's a table for normal test, F-test, and a chi-square test. So you need to come to the exam knowing them so that in the table, you know which table you have to use. This is a question about hypothesis, and I want to show you how to interpret, how to extract information from a question which is of hypothesis nature. What do they need you to know? They need you to understand, do you know how to differentiate the variance, standard deviation, how to get the significance level, how to know the null hypothesis and the alternative hypothesis, the population mean and the sample mean, you need to know. An observation was made about reading abilities of females and males. The observation leads to a conclusion that females are faster readers than males. This is a hypothesis. This is an opinion, a claim, an assumption, but it has to be tested. The observation was based on the times taken by both females and males when reading out a list of names during graduation ceremonies at Iqbal grounds. In order to investigate into the observation and the consequent conclusion, a sample of 200 men. So which one are you using? Are we using normal t-test? We're using normal. Normal means that more than, the sample has to be more than 30. They were given to read. On average, each man took 63 seconds with a standard deviation of 4. So the variance is known. They've given us standard deviation, we can know the variance. So still we have to use normal distribution. A sample of 250 men, this one's also more than 30, was taken and asked to read the list of the names. It was found out that the average took 62 seconds with a standard deviation of 1 second. Then they tell you, by constructing a statistical hypothesis at 1% level of significance, establish whether the sample data obtained does support either observation or not. Does it support or not? So there are two things. There is one which will support and there is another one which will not support. The one which supports is what we call the null hypothesis, and the one which does not support is called the alternative hypothesis. So these are the steps. One, you state the hypothesis. The null hypothesis, what are we talking about here before we test, is the difference between means. Now, what I want to tell you here, these are the 4 things we want to test when we're dealing with hypothesis testing. One, the sample mean or the population mean, the difference between the means, proportion, the difference between proportion. Those 4, you need to know how to differentiate them. But this one is talking about the difference between the means because they've given you 2 means. There is this one, 62 for men, and there's also 63. This is for women. Yes, 63 for men. And each has a standard deviation. For men, it has 4, and then for women is 1. And we also have the sample sizes, 200 and 250. So we can do this using, you can do the proportion. Now, the first thing you have to do is you state the hypothesis. The first one is the null hypothesis, which supports the observation that females are faster readers than men. The null hypothesis is supporting what is the claim, the assumption, the claim, or the opinion, which is always there. But the alternative comes now to not to support it. It's a different idea. This one they say females are fast readers than men. But these ones are saying, the second one says no. Females are not fast readers than men. So we're going to see who is right. We're going to test between these 2, the null hypothesis and the alternative hypothesis. The null hypothesis says mean 1 is equal to mean 2. The alternative says mean 1 is not equal to mean 2. Not equal means it may be less or it may be greater. Mean 1 may be less than mean 2, or mean 1 may be greater than mean 2, or mean 2 may be greater than mean 1. How do we test now? Since there is a sign of this sign not equal, it means we have 2 sides. Mean 1 may be greater, mean 2 may be greater, mean 1 may be less. So we'll have what we call two-tailed test. What is a two-tailed test? Let me draw this graph here down. The two-tailed is this one. This is a tail, this is a tail. If we had 1, how does the hypothesis test when it has to be 1? What shows that this hypothesis has a one-tailed test is when they say mean 1 is greater than mean 2, or they say mean 1 is less than mean 2. That will show you that there is a hypothesis. This one is equal to this, but this one would say, this one may say mean 1 is greater than mean 2, and this one may say mean 1 is less than mean 2. Then it means you'll be having one side. But when they give you equal or not equal, it means that you have two different sides, which we call the two-tailed test. And the level of significance is 1%. Since 1% is on a two-tailed test, we're going to get 1%, we divide by 2. What are we testing? The test statistic is the difference between the sample means, and the sample means are 63 seconds and 62 seconds. So it's the difference between those two sample means. Then the critical values of the tail test is 1% level of significance. 1% level of significance is obtained from the table, and this 1% is where we base ourselves. We're going to have critical value and standardized value. We compare the critical value and the standardized value from the graph and from the table, and then we get to know whether it is in the null hypothesis or alternative. Now, this region which is not shaded, this one in between this one, this is the one which supports. But if we get any here or here, it will be alternative. So this unshaded region is the null hypothesis. The shaded region is the alternative hypothesis. The critical values obtained by, since this is a two-tailed test, we're going to get 1%. We divide by 2. We're going to get 0.050. We read these numbers, both sides on this side and this side from the table, and we see what it gives. Let's go and read. Because we are dealing with a normal distribution, we're going to read from the table of normal distribution. If it were a t-test, you read from the t-test. So we read from normal distribution table, where we have 0.005. Let's check 0.005. Zero 0.005. 0.051 is more, 0.052 is more. We take this one. When you round off, it becomes, or in some papers, some books, they say you get this one, add this one, you get the difference between the two. You can do it that way, you get this one. It means that it's between 2.57 and 2.58. But you can also take this one, which is slightly below, because when you round off, this would be 5. So you say the critical path, the critical value will be -258. So since it is since this one is two-sided or two-tailed, you're going to write that figure that we got first from the negative side. You write it on two sides, and you say the 2.25 is here and here. Yes, this one is -2.5, and this one is -2.5, meaning it's here, here. So the region from here to here, 2.5 negative, 2.5 positive, is null hypothesis, and whatever is beyond 2.5, 2.58 negative and 2.58 positive, whatever is beyond will be taken to be alternative. So you go to the standardized value of the difference between sample means. These ones are critical values. Look for the standardized value, and this is the formula for difference between two means. X bar 1, X bar 2. How do you get this? X bar 1 and X bar 2. X bar 1 is the mean, sample mean for the first. And X bar 2 will be the mean for the second female. They are given here. S1 is 4, S2 is 1. These are standard deviations for the two. N1 for male, N2 for female. That is the sample size. Then you plug into this formula. It is given here. Then you get 3.45. Even this one is Z, but this one is critical value, while this one is standardized value. If the standardized value is between here, the null hypothesis taken to be, it will be accepted. If it's beyond, then the null hypothesis will be rejected and alternative hypothesis will be accepted. What does that mean? We have 3.45, which is greater than 2.58, which is within the region which is shaded. Then the decision will be that since 3.45 is greater than 2.58, we reject the null hypothesis and accept the alternative hypothesis at 1% level of significance, which means that the sample data does not support the observation that females are fast readers than men. It means that females are not fast readers than men, to depend on how they are reading or what they are reading. Someone who does not know how to pronounce the names, Rwandan names, does not read them very well, then you will not say that it's because he's fast. No, it's not always that case. It will depend on some other factors. This is one question on our alternative, hypothesis testing. I didn't pick all, I just picked few, just to show you how it can be done or how to interpret. Another question says, Nivea industrial manufacturers have produced deodorants known as Nivea for Men. In order to test its popularity in the market, the manufacturer carried out a random survey in Kigali city where 10,000 consumers were interviewed, after which 7,200 showed preferences. The manufacturer also moved to the same area. We interviewed 12,000 customers, out of which 10,000 showed preference for the product. Now, when you read this, out of this, that means there's a proportion. For instance, here saying 12,000 were interviewed, but out of the 12,000, 10 showed preference. This is proportion. And since there are two, there's one for one city and the other one for another city. This means the differences in proportion. The first one was showing differences in mean. This one is showing differences in proportion. Telling you to design a statistical test and hence use it to advise the manufacturer regarding to the differences in the proportion at 5% level of significance. The first hypothesis will say that first proportion is the same as the second. The preference for the first is the same as that one for the second. The alternative, you say no, they are not the same. Is the first proportion the same as the second proportion? Yes. First hypothesis says that. The second hypothesis, which is the alternative, we said they're not. So we're going to test the critical value. The critical value is two-tailed test because we have two sides. Then we get 5% divided by 2 at level of significance. Again, to get 1.96. 5% divided by 2, we get 0.25. 0.025. If you go to the table, you look for 0.025. 0.025 is here. You can check it here. which is negative 1.96. It's 6 or 7? 6 here. 1.96. You get this one. You get this. It has to be both sides because it's a two-tailed test. Test statistic is the difference in proportions. That's what we're testing. Differences in proportion. Standardized value, which we're going to compare against the critical value, is going to be obtained through this formula. You need to know the formula. When we plug into the formula, the whole of this formula, you first get the proportions, which are given here. Then N1, N2, you plug them into the formula, and then you're going to get the value, which is 19.6. Under the normal distribution, it means it is between negative 1.96 and positive 1.96. But here we're getting 19.6. So 19.6 is greater than 1.96. Therefore, since 19.6 is greater than 1.96, we reject the null hypothesis, but accept the alternative hypothesis at 5% level of significance, and we said the reason or what it means. The differences between the proportions are statistically significant, and this means that the deodorant is much more popular in Gisenyi than in Kigali City, so they are different. Yeah, this question was also asking about proportions. It's made the difference between the population means. We are not going to talk this one. This one is the same as what you've done there. Yes. So the most important thing is to know how to state the alternatives, where to get the critical value, and where to get the standardized value, and how to compare the critical value and the standardized value, and how to come up with the conclusion when they are given. So the next one, which is common also, is the linear programming. This one is where I started by showing you how to interpret, how to extract the information from the question. Now, let me advise you, if you find a linear programming problem, all the 7 questions are there, and you can all attempt all of them. This one is the simplest. But if they ask you, if you find there are 3 variables, X, Y, Z, do this question last. If this question has A, B, C, and maybe C is on linear programming, A is on transportation, B is on assignment, or game theory, anything. The one which has the simplex method, because I want to show you which questions will take you too long. All the questions you can attempt if you have read very well. But if you find this question has more than 2 variables, meaning you're going to use what we call the simplex method, do it last. Or do 5 questions and do it as number 6. Because you're allowed, you can do even 6 if you have time. But don't start with this question fast. To consume your time, because you know when you're dealing with the simplex method, you have to draw many tables, what we call successive tables. This is one other tactic I'm giving you to know how you're going to pass. But if you have two variables like this one here, they're just two. Do it very fast because linear programming is one of the simplest questions if you have thoroughly understood the question and you can do it. Do it very fast. For instance, a linear programming model, the marks are around 3, 4 to 5. So we cannot miss those four marks. The marks are between 3, 4, 5. Most especially 3, 4, 5. That's most common 4 for linear programming model. Now, why don't you do a model in 4 minutes and finish and then start drawing? Or if it is the simplex, do that part, leave the simplex part and go to the other questions and then come back to the simplex method later after you've done with the other questions. There is one other way to attempt this question if you are there, and it's common. This question is common. Use graphical method to solve the linear programming model. We have done the model. Let's first see how you drive the model. How many variables do we have? We have chairs, tables. There are 2. Chairs and tables, there are only 2. What are the constraints? Which constraints do we have? The company has to buy materials. Each requires that of material. Each table requires that of material. It means this is one which is about material. Each table requires 15 hours and each chair requires 4 hours. There are 1,950 hours for crafts each month. The company has budgeted to sell the chair at 80 and the table at that one. The production plan is to maximize the potential income. Now, I told you maximization is about income, it's about profit or contribution. So this, you first get this one out. Having gotten this out, it means this is the objective function. You call chairs X, tables Y. The first one should be X, the second one should be Y. Or it should be X1 and then X2 if you're using X1 and X2. And X1 should be on the horizontal, X2 should be on the vertical part of your graph. Linear programming model is composed of what? It's composed of decision variables, objective function, and the constraints. So this one is the first. The decision variables, you have defined them. Let the number of chairs be X, let the number of tables be Y. There is a mark there. The other one, the objective function is to maximize profit, general income. And this one will be 80,000 X and 350 Y, 1000 Y. There is a mark for that one. And here there also a mark for these two. How many constraints do we have? I told you, if you want to know the constraints, look for the units. These ones are francs. These ones, francs. After removing these francs for the objective function, the rest will be the constraint. These ones are hours. You look for hours, here hours, and here hours. If you had something else like kilograms, you go for that. If you had something else like what? Any other units, you also go for it. Those units will be differentiating the constraints from one to another. So you state them here like this. We have material constraint and time constraint, and don't forget to put the negativity constraints. Since this is a maximization problem, we'll be having less or equal to for the main constraint and greater or equal to for the non-negativity constraints. Now, having obtained this linear programming model, the next thing you'll do is to get the coordinates. The coordinates are not obtained from the objective function, but from the constraints. If you have 2 constraints, you have 2 lines. If you have 3 constraints, you have 3 lines. If you are being asked about the slack or the surplus, if you have 3 constraints, you have 3 slack variables. If you have 2, you have 2 slack variables or surplus variables, depending on what you're asked. So that was A. Then 2, use graphical method. Graphical method is used when you have only 2 variables, only 2. But if you have more than 2, even if they don't tell you the method, automatically you have to know that you have to use the simplex method, because simplex method is used when you are dealing with more than 2 variables, even 2. From 2 and above, you use simplex method. These are the coordinates, you can see them. So you can say let x be 0. For convenience, you can say 0, 1, 2, 3, but don't take time drawing all those points, because you'll not have time for saying let x be 0, let it be 1, let it be 2, let it be -5, like that. Just say 1, let x be 1, y will be something, or let x be 0, y will be something, and then you just estimate the point on the graph. The most important thing in drawing, I didn't put the title, but you have to put the title here. This title can be, because every graph has to be having a title, a graph of chairs against tables, or a graph of y against a simple title like that, against x, meaning you are going to have a graph which has y axis and x axis. Now you bring these coordinates here, you look which one has the highest. This 500 is on x, the first ones are x, the second ones are y. This 487 is also on x. So the highest on x is 500 and the highest on y is 130. Just as I told you previously, you don't need to get from 1 to 500. You just can say 100, 200, 300, 400, 500, or both sides, down and up. Or up, you can say 50, 50, 50, 100, 150. Or you can say 10, 10 up to 130. Or you can say 20, 20 up to 130, depending. But what you need to know, what you need to do is that your graph should be big. If you want, take the whole page, because if you don't draw a very clear graph, the examiner may lose some marks. The examiner is trying to figure out the table, the graph, and you find he's losing. A big space like this or more can be fine for you. In this one, I put a small space, but I could increase from 50 to 130, and I put it up to here, 130, so that this space is also covered. And this space here with the one up should be proportional. Don't draw up to small space up to here, and this one is tall, this one is short, or this one the length is it's longer than the height. Let it be proportional, and draw if you're drawing a graph, a table, a probability tree, or even the decision tree, draw bigger. Take the whole. If you want, you can even make sure that your paper, the booklet, is in the landscape form. If you cannot do it in a portrait, do it in the landscape. This one. The landscape is, turn it like this and draw a very good diagram. A diagram is very important. You miss the diagram, miss marks. You draw it poorly, you miss marks, because the examiner will not figure out what you have done. Then what you need to do, put these coordinates on each point. You never know. He's marking maybe this coordinate, he's marking this point, and name the line. If this line was from this equation, put it there. If the second one was from the second equation, put it there and shade. You may shade this one. You may shade the region you want, or you may shade the region you don't want. But whichever, because different books will show different ways. A book that you read may show that the shaded region, the feasible region is shaded, and the other book may show you the unwanted region is shaded, which is not feasible. But whichever, whether you're shading this part, whether you're shading here like this, the one which you don't want, you're shading this other part like this, from here, like this. You may shade that part, or you may shade the one below. Whether you're shading this one or this one, write this word, feasible region. Because if you don't write that one, you will not know which region is feasible. Whichever part you shade, show the feasible region. I'm not saying you shade the upper part or the lower part. It will depend on what you want, but just tell them the feasible region is here. What does the feasible region mean? The points which have maximum profit or income are within this region that is shaded. And if you want the maximum one, you get A, B. B is the intersection of these two lines, and C and D. But for D, you can leave it. Then take these coordinates between these two lines of each of the lines and substitute it in the objective function. After substituting in the objective function, you get the profit. Yes, very important. Draw the graph, very big one. Show the coordinates, show the lines, draw the lines, show the feasible region, put a title, show the axis. This is x-axis, up is y-axis. Show it. Oh, it's x1 down here, and this is x2 up here. Don't draw the graph and let it hang without any information in the graph. Then you have those points which you suspect should be having the highest profit, like A, B, C, D. Then you plug in these ones into this objective function and pick the one which has the highest. This is in the case of maximization problem, but in case of minimization problem, you can take the one which has the lowest, because linear programming is a decision making under certainty. Yeah, did they ask us Slack? Had the simplex tableau, method tableau been used, the Slack variables would be used. Set what the Slack variables would have represented and their values at the solution level. What is a Slack variable? For maximization, we use Slack variables. For minimization, we use surplus variables. Now, Slack variables, these are unused resources. Let me go back to the graph, I mean to the lines, the constraints. These constraints show what is going to be used. For instance, this one says we can use 2 of x and 10 of y. If we multiply the 2 units with these variables, we have to use less than 1,000 or equal to 1,000. You may use 1,000 or less. Now, if we use 1,000, we'll have used all the materials. If we use less than 1,000, we'll have used, maybe let's say we use 9,000. It means 100 is a slack. That is a slack variable. 100 worth materials have not been used. Here, this is about time. We are given 1,950 hours. But did we use the 1,950 hours? We may have used less, or we may have used everything. Now that we're going to be tested using the slack variables. So you make these ones equations. They are no longer inequalities, you change them into equations. Then you substitute using the optimum solution. Optimum solution is this one, the one which gives the highest. This is the optimum solution. This optimum solution is the one which you're going to substitute in the slack variables or the slack equations to get the slack variables. So the first one is 2x plus 10y plus s1. S1 means slack variable 1 because of constraint 1 is equal to 1,000. And the reason we're adding it here is to add the resources that would be missing or remaining. This one also is time. The time that would be remaining to complete the 1,950. This one is what we take. If you don't take the feasible optimal solution, you will not get the right thing. You have to use the optimum solution always. When we plug in these values into this equation, we are going to find that the slack variable is 0. 1,000 here is equal to 1,000. What does that mean? It means that all the materials, the slack variable for the first constraint is 0, meaning all resources, specifically the materials, were used. Everything was used. Time. If we plug them here, you find 1,950. 1,950. Is it the right answer? 400 times 400, 450. 450 times 4. 1,800 plus 150 is 1,950. So this one is 1,950. All the resources were used. Yes, all the time, all the hours were used. There's nothing that remained unused. The question was asking, comment on any practical difficulty that may be involved with the solution of this problem. What would be the problem? What would be the difficulty in calculating the problem? Yes, it's asking, what are the difference between minimization and maximization in simplex? In simplex method, the minimization we call them surplus. These ones, instead of slack, we call them surplus. Surplus means you used beyond, you used more than what was given. In maximization, we used below, something that was less. Because remember, in maximization, in minimization, we may have something like this: 2x plus 3y. This one has to be greater or equal to. Remember, the signs also have to matter. Greater or equal to. We use this one. Greater or equal to 3,000. For instance, I'm giving you an example. What does this mean? The lowest, 3,000 is the lowest. If this is time, 3,000 hours. We have 3,000 hours as the lowest. You can use 3,000 or beyond. Now, when you use more than 3,000, when you plug them here, the optimum solution, and you plug it here, and you get 3,000, it means you have used all the resources. But if you plug and you get more than 3,000, it means you have used more than what was given, and it's allowed, you can use more. Because that statement says 3,000 or more. Yes. That's what the slack and surplus means. Yes, I think on linear programming. Yes, this question was asking what difficult, practical difficulty do you get that may be faced when finding the solution. So the finding the coordinates from the constraints and sketching the graph is one of the difficulties that may be involved in solving the problem. How to trace, how to draw the graph, how to find the coordinates, even sketching the graph is problematic and is one of the challenges. The reason they're asking this is because the challenge the students meet when they're drawing. Yes. Now, in ICPAR syllabus, linear programming, transportation, and assignment, they're under one chapter. You have to know that they're under one chapter. All of them, they're taken to be one chapter. So, and they are confusing. So I'm bringing this question down immediately after linear programming because it's one chapter. But otherwise, I would have separated and said transportation, assignment, linear programming separately, but they are only one chapter. And if you're reading and you are reading on linear programming, you have to know assignment and transportation in the syllabus. And what I want to tell you, you don't have to read, maybe you have used SCCA material, you have used CASNEB material to read, whether you read SCCA or CASNEB, but confine yourself to the learning materials of ICPAL, confine yourself to the material of ICPAL, the syllabus. Don't go beyond the syllabus, read it for information, for understanding, but go by the syllabus. Yes, here we're saying this is another question and a tricky one. This is a tricky question which I need you to understand. And this is the question I was telling you up there when we were starting. This is a question on, you don't know, is it transportation? Is it assignment? I told you the difference between transportation and assignment is that what transportation will have the capacity and the requirement, or the supply and the demand. The supply capacity is for the factory and the site requirement is for the building. So these are the totals which have to be down on the last row or the last column. But assignment does not have this, it does not have these two. That's the difference between the two. Don't confuse these two questions in the exam. And this is one of the simplest questions, the fastest. No, it may not be simplest, but fastest. There are some questions which you have to do very fast and you go. This question says a complete company wishes to transport tons of concrete slabs from factory 1, 2, and 3 to building sites A, B, and C. The plant factories have the capacity to supply tons of concrete slabs per week as follows. Now they have given you the total of the factory capacity, and they have given you the site requirement, each building the requirement. Now we are lucky. We have 3 plants, factory plants, and 3 sites. You may ask, how is this related to the table below? Why do I need to do with these values, these small tables? These tables are just adding them in this one, the main one. If this part was not given the exam, this one and this one down, they just give you, for instance, let's delete this one for a moment, and we delete this one also. The question may be asked in this form. Given, the question may be given like this. This question is not complete when you don't have these ones. Actually, the question has to be in this form. So if the question is this form, you may tend to think this one is an assignment problem. But remember, assignment is also, they will show you the task, they show the people doing the task or the machine doing the task. But here they're showing you the site, they're showing the factory, meaning that you're moving from one factory to the site. You can move from factory 1 to A, factory 1 to B, factory 1 to site C, or 2 to A to B to C, 3 to A to B to C. But this one is also not complete. The question is not complete. So these small tables are there to help you to plug what is supposed to be here and what is supposed to be below. If the examiner gives you everything, fine, you are okay, just go straight. If he gives you something like this, bring these tables, these values into the table and do it, just as I've shown you. Like this, you put this one down, you have put this one here, this one, then you put another one down. The question is complete. And what you have to do is to check the total of these three and the total of these three. Are they giving you 700? 100 plus 300 plus 300, 700. 300 plus 200 plus 200, 700. Then you can now start doing this question. And you also have to go by the requirement. We started by the requirement. What does the requirement say? They have told us to use northwest corner rule. Now you don't have to say, I didn't understand northwest corner rule, but I understood Vogel's approximation method or the least cost method. That's what I'm going to use. If you do that, you will not get anything. Go by the instruction, go by the requirement. So northwest corner rule, I hope you have studied this one, you have revised enough, you have done many questions, practical questions, try to practice. If you have practiced, you know where to do. Now, because of drawing, I didn't put here the northwest corner. We have to do like this. Let me come back a bit. Because of the drawing, the table, I didn't put it there, but let me show you how to do it. Anyway, I'll try to do it. Northwest corner, you have to get this here. This is northwest. Go like this. Why? What's happening? Anyway, northwest corner, you have to have a box like this. Now, in the northwest corner is here, this one. That's where you have to write. For instance, 100. We took 100. This 100 is one which you took. You have to write 100 here. And your 5. The 5 is the cost of transportation here. Like this. You go to another one that way, you go to another one that way. But all the other methods, you don't need to do this one because for them, there's no need of drawing northwest corner or anything like that. So how do you start with the northwest corner? You start from the first column, you compare what is the supply and the capacity. If the capacity is less than the supply, you plug in the capacity, and then this one is covered, you remain with 0 here. But here you're remaining with 200 because you filled 100. 200 will be filled with 300 minus 100, you remain with 200. Since the first row is covered, you go to the second row. You compare 200 and 300. 200 is less. You put 200 here. So it means you're going to draw another one here, like this. You put your 200 there. With 8. It means this whole column is covered. The first row is covered, remaining with the second column and the third column and the third row. So what is remaining here is 100 because we filled 200 here, and this one is 0. 300 minus 200 is 100. You compare 100 here and 200 this one. You're comparing this, the remaining, with this one. 100 is less than 200. You take the lowest. You bring 200 here. So this one is here, like this. Put it in the northwest corner in here. This is 100. And you have 4 here. It means this one is covered also because 200 plus 100 is 300, which is 0. 100, 200 is 300, which is 0. Here we're remaining with 100. 100 you compare with the 200. 100 is less than 200. You put 100 here. So you bring it here like this. This is 100. And you put 7 here. Then what remains is 200. 200 also goes to this side. Northwest corner like this. What you have, 200 like this, and here you have 5. It means this one is covered, the whole of this one is covered, this row is covered, and this row is also covered, and this one is also covered like this. This is your table. Like this. Sorry. Anyway, that way. You draw a good table in this form and then you show it here. Now these ones are the ones you're going to multiply. 100 times 5, 200 plus 200 times 8 plus 100 times 4 plus 100 times 7 plus 200 times 5 to get to the total. Practice this question, practice doing all of them, least cost, Vogel's approximation, low minima, Coro minima, northwest corner, all of them, practice them, and then come to the exam when you're ready to do whichever you ask. Don't figure out your own question. Don't put your own question because you will not pass that one. The examiner will not tolerate, will not say he didn't know northwest corner, he tried to do Vogel's approximation. Let's be lenient with him or her. So they're saying interpret the values in one and determine the initial feasible transport cost for these factories. Now you can see we have 100, this one, the 100. And the interpretation is this: factory 1 supplied 100 tons of concrete slabs to site A. They supply this one. Only factory 1 supplied only site A. Factory 2 supplied 200 tons of concrete slabs, which are these ones, to A, and also supplied 100 to B. Factory 3 supplied 100 to B and 200 to C, because 200 required only, C required 200. So out of the 300 factory 3 had supplied 200 to C, and a part of what was remaining on B was supplied by 3. So that is how we interpret. Interpreting means the examiner wants to know, did you understand after drawing? Did you understand what you were drawing? Did you understand what it meant? And those ones which are inside are the transportation cost. It means that transporting from factory 1 to site A, it takes 5. This one is the transportation cost. From 2 to A is 8. From 3 to A is 9. So he wants to know which appropriate way can you assign, can you transport from one side to another? That's what they need you to understand. If you can distinguish the supply, the transportation cost, the capacity from the site or the origin to the destination, then you understand, you know. And then drawing the total cost is just multiplying whatever you got and add them up. And then you get the lowest. What does that mean? In that form, for factory 1 to A, 2 sites, and 3 supplying these 2 sites would be the minimum. That is the lowest transportation. If you don't do it in that form, any other way you do it will make sure that this cost is more. This is the lowest. This is the this is the lowest. This is the right design that will give you the lowest transportation cost. And we call this one initial feasible transportation cost, or initial feasible transport cost. I hope you have understood, or you can follow, you know how to do. I've shown you how the examiner may interpret, may give you the question, or even the examiner may not give even these tables, this one, and this one. He'll give you everything. The examiner may give you everything in the sentence up in a paragraph form. You need to understand. For instance, the examiner may say, factory A is supplying concrete slabs to sites. Factories are supplying to sites. Factory 1 is supplying the transport cost of supplying the concrete slabs from factory 1 to A, B, C are 5, 4, 3 respectively. From factory 2 to site A, B, C are 8, 4, 3 respectively. He's writing the sentences, not the table. The transportation cost from factory 3 to site A, B, C are 9, 7, 5 respectively. And the total capacity of factory A, factory 1 is 100. The total capacity of the factories are 100, 300, 300 respectively. The total demands for the sites A, B, C are 300, 200, and 200 respectively. Then he's done. There's no table either of this one or this one or this one. Everything is in a sentence, in the paragraph. You need to know how to do that. Is it allowed to add dummy supply or dummy demand when not equal? When they ask to draw the network, that they want to tell us? Yeah, we didn't talk on the network. In the network, you can draw what we call it a dummy activity. We didn't talk about that. But in transportation, you don't need a dummy supply or capacity. Dummy supply or requirements. It means in transportation, you may have 3 sites and 4 factories, or you may have 4 factories and 3 sites. But in assignment, you need to have a dummy. Don't have an assignment question, and I show you. Let me pick somewhere a question here. Maybe it may not be in the next past paper, but let me answer that. Assignment. For assignment problems, please. Assignment, you have to put a dummy. A very good question. For assignments, you have to have a dummy. For transportation, no need of a dummy. Where's the assignment? Yes, assignment problem. The assignment problem looks like this. The assignment problem looks like this. The position, the workers. 1, 2, 3, 4. 1, 2, 3, 4. There's no need of capacity. There's no need of supply. The assignment problem is this way. But in assignment problem, you need, if there is a dummy, if they are not balanced, we call them unbalanced. If they are not balanced, you have to look for a dummy. Let me give you an example here. Yes, an example is this one. The machines are X, Y, Z, W. The workers are 1, 2, 3. You can see we have 4 columns and 3 rows. This, you cannot do this question unless you introduce a dummy. A dummy is what? Whatever is lacking, whether the row is lacking, you put the dummy, you put another row down like this. You put it down here. You create another one which has 4 and you put zeros because they are not there. If it is the column that is missing, put a column here for assignment problem. For transportation problems, don't need to put any dummy column or any dummy row. For network, create a dummy. How do we create a dummy in the network? So what can we do when the supply is not equal for transportation problem? Transportation problem, maybe if you are talking about the capacity and you cannot solve that problem, my friend. What has to be equal is this one, this total. But for the columns and rows, that one don't need to bother. For transportation, even if you had A, B, C, D, F, G, and here we had 1, 2, 3, the most important thing is this total to be equal. If this total is not equal, you not solve that problem. It not be easy to solve that problem in a normal way, unless you use a computerized software. But it's also not be easy for you to solve it. One of the assumptions, one of the requirements for you to do a transportation problem is that this one, the assumption, this is a model, remember, is that this should be equal. The total supply should be equal to the total demand. I hope you read about the, let me give you the assumptions that you have to follow for the model to work. What are the assumptions to follow? For this model to work, these are the assumptions. Assumption number one says, the model assumes homogeneous commodity, one type of the commodity. What does that mean? If we are supplying beverages, that is it. If you're supplying milk, it's milk. You don't mix milk and juice. We're dealing with one commodity. Total supply is equal to total demand. What do we mean? If you get the total capacity and the total requirement, it has to be equal. If it's not equal, this model will not work. The unit shipping payoff should be known. The transportation cost we talked about in the table should be known, transporting from the site, from the source to the destination. The requirement at the destination and the units at the source must also be known. This is what we are saying. The requirement at the source here, the requirement here, the requirement down, and the supply here must be known. The units of transporting from one place to another should be known, like this. And this one, the supply and the demand must be equal. Those are the assumptions of this model. The units can be shipped or transported from any source to any destination. What does that mean? It means you can get from F1 to W1 to W2 to W3 to Wn, anywhere, and 2 like that, and Fn likewise. This last one, I want you to see this one. It's not a must that there should be a balance between the number of sources and number of destinations. What does that mean? It means the rows and columns should not be equal. It's not a must that they have to be equal. For instance, here we have warehouse 1, warehouse 2, warehouse 3, warehouse 4, factory 1, factory 2, factory 3. The most important thing is this one. Whether we have 5 columns and 2 rows, you need to know that the capacity and the supply, the capacity and the demand, or the supply and the demand are equal. That's the most important thing with transportation. But for assignment, they have to be equal. You have to balance the rows and columns to be able to deal with the assignment problem. I hope I'm clear now. Okay. Yeah, this is what they are done with that one. Our time is running out. Another question is this one, time series. Another one which is most common and which you have to come to the exam knowing to do is this one. But I advise you, if you can find some other questions which you can do very fast. Anyway, I advise you to do this question last. Spare the 36 minutes. If you can do them within 25 minutes, every question, spare time for the time series. Time series is one of the questions which is longer. Time series, simplex, drawings, the network, what else? Yes, those ones are the longest. I'm not saying they are the hardest. They are simple but long. They can be done, but they can take time. You can do them, but it will take you time. So do this question last. After I've done 5 questions, if you can get 5 questions very fast, go and do this one last as a supplement. He says asking, what can I do when the demand and supply does not equal in transportation problem? Help me. I said it is an assumption for the model to work. And whenever there is an assumption for a model, it means that model cannot work without that assumption being fulfilled. And that is one, if they ask you, what are the limitations of transportation problem? You will say one of the limitations of transportation problems is that it assumes that the demand has to be equal to the supply. But what if the demand is not equal to the supply? Then the problem cannot work, cannot be solved. So that's what I'm saying. They will not ask you this question because the assumption is that the demand and the supply should be equal. And that's what the first thing you have to know. If it is not equal, if it's not equal, what can you do? Let's see. We said it doesn't need to be, it doesn't require you to have the same columns and the same rows. If it is the examiner who asked it, you don't have to change. You leave it, then they will mark the way it was. But if you are the one you are practicing, for instance, now we are practicing, and you find in a question that you are practicing, you are doing a revision, it is not equal. Try to equalize it. Try to find out to equalize the rows and columns. See where to reduce and where to increase. But that is, you're changing your own question for revision. But in the exam, you cannot change the question. You cannot change the question. Once the question is set, it has to be that way. You cannot change. But they will not ask you a question where the demand and supply are not equal, because they have seen that that is an assumption that allows the model to work, meaning that the model cannot work when that assumption is not fulfilled. And that's one of the limitations of the assumptions. So please don't worry. The examiner will not ask you what is not workable. The examiner will ask you what, even the examiner himself will if they have solved that problem, it cannot be solved when they don't balance, when the supply is not balancing with it's like asking me that what happens when the credit side is not equal to the debit side? What happens when the assets are not equal to liabilities and equity? What happens? It means there's a problem with that question. There's a problem in not balancing out the question. You cannot do the balance sheet and it keeps hanging without being balanced. It has to be balanced. So the same with this one. Okay, time is running out. I don't know whether we'll have another time of revision so that we'll go through the remaining topics and I show you how to extract information and how to, for instance, I was going to show you how to do this question very fast. This question asks us the how many years for, how many quarters for, so there are many. Imagine 4 times 4 is 16. Now here, they ask you 4-point moving trend. If they're asking 4-point moving trend, it means that is 4 centered moving average. When there are 4, 6, 8 like that, they have to be centered. If they are odd, like 3, 5, 7, you don't need to center them because the center is automatically given. So 4-point moving trend means 4 centered moving trend. And what is the trend? In tenses, we have 4 components: the trend, the seasonal, cyclic, and the regular. The trend is the one which we are dealing with when we are dealing with moving average. We have 4 methods for finding the trend. We have freehand, we have moving average, we have least square method. So whichever the examiner decides, we will ask. Now, how do we get the 4-point moving average? Moving means they are moving together. We are moving in the batch of 4, 4, 4. If it's 4 points or 4 centered, it means you're moving in a batch of 4, 4. You're taking 4, 4, 4, 4 together, like this. We're going to, let me take it down. Now, this question, if they've given you many years and the quarters, you have to have the whole page. You can even do you can even have a booklet and do it 2 pages. because it will be too long. It will be too long for you. So you do it on 2 pages, and 1 page this side and that one, and you put it in the how do we call it, in the landscape form. Because why am I saying that? You leave space between quarter 1 and 2, quarter 2 and 3, quarter 3 and 4. Now, how do we get the moving average? Moving average, if they are in 4, you get this one plus 4.1 plus 6.0 plus 6.5. You add them together, total will be 21.4. You divide by 4, you get 5.35. You write between quarter 2 and quarter 4, between quarter 2 and quarter 3, because you don't have a center. So this one will be written here between. That's why you have to leave space between these two. Then this is the moving average, the centered moving average. You're going to get this one and this one. You add them together, you divide by 2 and write in between, which means that this one, the total, the average corresponds to quarter 3. You do the second one like that. You keep going down, and then you get all of them done in that form. After getting this first 5, this first 4, you got the first 4 from 1 to 4. Here, you added them together. You leave out the first one. You move down. That's why you call it moving. You're moving another batch of 4. You get another batch of 4. This one, from here to here. You add, you divide, you get it here in this place. What is this? You leave out the first one and the second one. You go to the third one, take a batch of 4, like that. You write it here. You pick this one, you're moving in a batch of 4, you do that way. Now, how do you do this one very fast in the exam? Let me show you how you do it very fast in a simple way using your calculator. But this one requires you to be so smart so that because rubbing, and then if you rub and then you type in the calculator again, it will be difficult. So the first one you say 4.8 plus 4.1 plus 6 plus 6.5 gives you 21.4. Get 21.4 divided by 4, you get 5.35. Now do like this without erasing. Multiply by 4, multiply by 4. Multiply by 4, you get this total. You are going backwards now. After multiplying by 4, you get that total. You subtract 4.8. I'm subtracting this one. Let me show you here. I'm subtracting this because I'm going to a batch of 4. I'm taking this 4. I subtract that one and add this one, the fourth one. I subtract that one, I get 16.6. I add 5.8. I'll get 22.4. I divide by 4. I'll get 5.6, this one. I go back, I multiply by 4. I get 5.6. I mean, I'll get 22.4. 22.4. I subtract this one now, this one here, and add this. You have to be having 2 pencils. You tick the one which you have subtracted, you tick the one which you are adding. We subtract 4.1, we add 5.2. then we get this value here. You go on like that until the last one without changing anything from your calculator. Why am I saying that? Because this is one of the longest questions. If you are to subtract, or you go have on the draft on the back of the booklet, write up to this total, this one, subtract this one, add this. You put it there, you show it. You come, you do the second one, you subtract this one, you add that one, you show it. Go on like that until you get to the last one. Because if you don't do that, this is one of the questions which takes long. It's easy, but it's one of the longest questions which takes time. That's why I advised you to do it last. If you want to pass, do it last. But doing it last means you should have read 90% of what you are syllabus of everything that you need to study. So what do you do after doing this? You have these values, these ones. These are what we call moving average, centered moving average from the first year to the fourth year, quarter one to quarter four. After having them that way, the trend, they ask us the trend. The trend, for you to get trend, we know that time series, time series is trend is T times S times C times R or I. This is when we are using multiplicative model. If you're using additive model, you add them. Now, for you to get this trend, for you to get that trend, we call this one Y. Sometimes we call it Y is equal to Y divided by the whole of these ones together. S times C times I. So in time series, remember we have T times S times C times I. But this one, the question is saying the sales data provided by firm in media industry, quarterly data for, these are quarterly and for the year. Now, when they are quarterly for the year, it means we don't have C. We don't have C in our component because C takes more than 1 year. It means we don't have this C. So remaining is S and I. How do we eliminate I? I is eliminated through moving average. I, what is I? I is irregular variations. And how do you remove irregular variations from the time series data? This average, the average that we did first, this average, and this one, and this one, and this one, all these averages, the more we go on averaging, this one is eliminated. It's not eliminated completely, but eliminated partly, and we're going to be remaining with S. So our time series will be Y divided by S. C is not there because of annual sales. I is not there because it has been removed by averaging. So we'll be having Y and S. Now, when you get Y divided by S, you get the trend. So that was the trend. You get the Y divided by If you want this S, this is the trend. This is the trend already that we got. But if you want S, you get Y divided by T, and then you get S here. But the seasonal indices for each quarter, you could get them using the seasonal variation, which is the second. It's the second question down here. The second question says, the seasonalized data. So you first, before you do the seasonalized data, you have to get seasonal indices, and you get them in this way. But let's go back a bit. Now, when you have these ones, what will show you that this is a trend? This one. What shows you that this is time series and this is trend? With time series, you see the variation 4.8, 4.1. There is a reduction from quarter 1 to 2, then an increase from quarter 1, 4.1, 6, 6.5. So from quarter 2 to quarter 4, there is an increase. From quarter 4 to quarter 2, there is a decrease. From quarter 2 to quarter 4, there is an increase. That's what shows you that this is the trend. I mean the time series. But the trend is not in that way. Trend goes on increasing. 5.4, 8, 5.7, you see there is increase. 5.9, 6.1, 6.3, 6.